Welcome to episode 4 of Unity as a Concept. In the previous episode, we hit something of a milestone, transitioning from working in vanilla Unity to Big Kid TwistCone, where we started making our own components. Since the previous episode, I've been busy converting our little pachinko board from a gambling addiction to a small game. Our pachinko ball can now be controlled with the left and right arrow keys, and he dies after hitting 3 of our pegs. But not to worry, because we can hit the mouse button every now and then to prevent certain death. A link to the project is in the description below, and that's important, because I will not be going over how to make this, because this would be a much longer video. Instead, I want to talk about the idea of making something like this. So I'll be talking about ways you can build your components and what makes up a script. With any luck, you should be able to download the project and start understanding how to make things different in interesting ways. I've tried to build these components in adherence to component-based design, meaning that each component is responsible for as little as possible. I could have, of course, built one large component to slap on my pachinko ball that handled everything that happened in the game, and that would have worked no problem, but doing so comes with a couple of drawbacks. First, big components get messy. All the competing concerns and divergent responsibilities take a toll on the poor thing, turning it from the bright-eyed optimist to a hunchback monster by the end of the project. Second, you're going to do the same thing twice. Nay, 3 times. At least. Maybe 4. Right now, our ball is the only thing that moves, but who's to say that we don't want moving pegs in the future? It would be nice if we could reuse the stuff that was made to move the ball, but we can't do that unless we rip out a copy and put it in another monster somewhere else. So yes, your successes are in 2 places, but also your bugs. So instead, I broke my component into small, happy pieces. Each one does one-ish thing, but it does that one-ish thing really, really well. Now my pachinko ball is a David Hume fever dream, constructed from a bundle of components rather than one rigid one. These can stay lean and can freely be shared between existing objects. With that out of the way, let's select the simple falling controller to get started. At the top of the file, you'll see the using declarations. These are the names of packages of code that was pre-written that you're requesting to use. If you don't ask for them, you can't use them. And most of the things that we're going to be doing actually come from this one. The Unity engine contains all of the code specific to Unity stuff. If we want to do something with a Unity object, like a game object or a transform or another component, then we need to say that we want to use it. Next is the class declaration. This is where we begin to define the specifics of our component. The public keyword means that anyone can use it. The class keyword is a declaration of the type of C# thing that we want to make. C# has several things like structs and delegates, and of course classes. Each one has special properties that make it useful under certain circumstances, and classes just so happen to be the best fit for making components. Then it's the name of the component, which can be basically anything you want it to be, which leads us finally to the declaration of inherited classes and interfaces that we implement. You see, a class can inherit things from other classes. In this case, we're saying that simple falling controller inherits from monobehavior, Unity's way of saying component in code. And that means that we've inherited all of the things that a monobehavior knows and can do. Effectively, we've said that a simple falling controller is a type of monobehavior, a type of component. And by doing that, Unity will treat it as if it were any other component. Now we've made it to the meaty part of the simple falling controller, where we actually define what it is and does. These first bits are called fields. Fields are values or references that are used by your class to make decisions. A field is defined by its accessor, its type, and its name. Public means that anything can use the field, and it also means that Unity will expose these fields in the editor. Private, on the other hand, means that it can only be accessed within the class definition, but you can force it to appear in the editor by adding this attribute. Keeping things private makes it easier to guarantee that this component doesn't succumb to peer pressure and deviate from the one-ish thing that it was meant to do. It can be a little annoying to set up, but it saves on headaches later on. Fields can be virtually anything. The simplest types are these. Integers are used for numbers. Floats are used for numbers with a decimal point. Booleans are for true and false values, and strings are used for pieces of text. But fields can be more complicated things as well, like unity types, such as a rigid body, transform, game object, or sprite. But they can also be things that you've defined, like the player input handler, or the simple movement. Next, we have our methods. Methods encapsulate a set of simple operations so that the more complicated task that they represent can be reused or accessed simpler. A method can use the class's fields or external arguments to make a decision, or maybe just complete some larger action. Methods can be divided into two types in Unity: magic and, well, all of the other ones. Most of the methods that you write, like this one, have to be called directly in order for the code inside to be used. If not, everything inside will never execute. Magic methods, on the other hand, will be called by the Unity engine at certain points in an object's lifecycle. You don't have to call them. Here are the most common magic methods. Await gets called the second this component comes into existence, making it a good place for you to do all of your initial setup. Start will get called next, but only after all of the awake methods have been called on all of the components. This means it's good for finishing setup that might rely on external things. Update will get called every single frame, and late update will get called after every component has already called its update. So update might be a good place for moving something, while late update is a good place for following. Fixed update will happen on a known fixed interval. This makes it nice and predictable, which is great for updating physics. Then, depending on your frame rate, it could actually get called multiple times in a single frame. On destroy happens whenever your object is getting destroyed. Could be because you're done with it and destroyed it. Could be because the game is over and you're done with everything. This makes it a good place to clean up any mess your component might have made. And there are several others. Some that happen when you collide with something, some that happen during animations, and some that happen whenever the camera wants to draw you. You'll just have to check out the documentation for a model behavior to get a full picture. Now that we have a complete understanding of how all of Unity scripting works, we should take some time to actually dive into these scripts specifically in the next episode. Next time, we'll discuss some of the components in this project, which could get a little dense. In the meantime, please download it and play around with what I have. As always, leave questions in the comments and like and subscribe if you found this helpful. I'm a person, and thanks for watching.